Hi, this is Catherine Rabik, HRABIK, CSC 578, Homework 2 walkthrough. I'm going to talk really fast because I keep going over time here. So I'm sorry about that. I'm going to kind of be glazing over this first part pretty fast to get to the more complicated parts. For all the cost functions, really, these just came directly from the slide deck. So you have your function and then you have your derivative. Quadratic was already done. Cross entropy, again, something we've already kind of been over before. One thing to note is in a couple of cases, I did try and fiddle with it just to get those divide by zero errors and all the not a number value, issues we were running into to kind of go away. So that's why that's there. Also for log likelihood, this looks a little weird. The way I found to implement log likelihood, it returns as a list of one value. So I'm just taking the index of 0 of that list. That just gets it in the right format to kind of work with the rest of what we're doing. So if that looks a little weird, that's why that's there. Again, derivative just directly from the slide deck. For the activation function, sigmoid was already done. So for softmax, all you really do is you get the np.exp of the z value, and then you divide it by the sum of all those values, and then you just return it. Derivative for that was already done as well. Tan h, again, it's really just math. I mean, it comes directly from the slides again. So that's just, how it was implemented, and how the derivative comes through as well. So that does look, kind of familiar from our past homework assignments as well. So all of that was actually really easy to implement there. But the rectified linear unit one was a little bit different. So this is where you're trying to get everything positive. So you're taking the maximum of the value itself and 0. So if anything's negative, it comes up to 0. And then the derivative's kind of normalizing. So what it does is if it's over 0, rather than keeping the same value, it actually just reassigns to 1. And if it's 0, it just stays 0. So that's really just normalizing it so we get back a series of zeros and ones. Okay, so the network, per the recommendation on the homework assignment, if tan h is not with quadratic cost, it doesn't, the way we have everything written, it doesn't work. So it's just reassigning to sigmoid, per the recommendation. And I switched that in the convenience function as well. So let's come down here to feed forward. So this is where we're trying to make sure that it handles hidden layers different than output layers. So everything up until that last entry, the last activation, it's handling it as a hidden layer, as it should, and running the function as a hidden layer. And just for that very last one, which we know is the output, it handles it as an output. So let's see. Okay, so for updating mini batch, that's where the regularization comes in. I did spend a lot of time on this just because, all the other experiments on the HTML document were working perfectly. Aside from regularization, it's really close, but the values are a little bit off. So I spent quite a bit of time on this. One thing to notice here is the way the code was originally written, it kind of defaults to L2. So this is L2, which was kind of already present. And then this is L1. And you'll notice bias doesn't really change for either one, but for the weights, for L1 specifically, you do take the sign. Now, I did try NP sign, but for whatever reason, writing my own function did get me closer to the values I needed. So I wrote a version up here, which it's really, it's the exact same thing. It's, it's not written as well as the NP dot sign, but for whatever reason, this does work better for our case. So that's kind of where that comes in right here. And then backprop. So backprop also has to kind of carry through some of the same logic as feed forward had, where everything up until the last one is treated as a hidden activation, and everything just that That very last one, that's the output layer. So here is my attempt at dropout, and I will say that this is wrong for a lot of different reasons. So I'll spend a little time talking about that on here, but there's a lot in my write-up about what I did wrong. I unfortunately didn't notice until probably like a half an hour ago because for the experiments, it looked like it was working, but it doesn't work for mini batch of anything other than one. And there's a couple different reasons. So what I did was in SGD, because this is where we're really dealing with the training data, for the mini batch itself, I tried to assign I tried to create the dropout mask. So if we actually have a dropout percent, I tried to create the random binomial, and then you take the 1 minus dropout percent for the right hold back there. This is where the problem is. So mini batch comes in as a list, but that doesn't vectorize properly. So if you get something that's, if you have something that's, multidimensional, this just doesn't work. So I assigned the dropout mask here, and I actually created a field in it for that. And then I actually utilize it down in back prop. So here's where I tried to utilize it. And there's some things wrong with this as well. So I tried to avoid the input layer and the output layer, but then for whatever reason, I'm trying to take the whole length of the activation. So up until here, that's the input layer and all the hidden layers. So that needs fixed as well. And then I'm trying to reassign that activation value times the appropriate index in the dropout mask. But this is where that problem is because we're working in multiple dimensions here, and it doesn't transform properly because there's no easy way that I found that would work to actually multiply that correctly. So I definitely screwed that up. There's a whole part in the write-up about what I had done wrong, so I'm not going to focus too hard on that. And then one last thing here, total cost also has to handle regularization. So again, L2 was sort of the default, so that was already kind of here. So we're really just changing L1. So that's where you have to take the absolute value. And I believe that's it. So you just add the cost plus that extra the extra value. So and if so essentially if it's L1 this way, if it's nothing, or if it's specified L2, since this was already hard coded, it just defaults to this. All right, thank you so much, and have a good day.